Page 36 now. So page 36. Luke. Got your email, by the way. Hey, listen, come on, stop talking now. We're starting. Integration of proper partial fractions. Joshua, what could possibly be the problem? You're asking him what? What are the other math classes? Well, take out your book and go to the page previous. Come on. It's not rocket science. Okay, so integration of proper partial fractions. Now guys, look, before I start, yesterday there was a mess on the carpet, and the student who didn't make the mess kindly cleaned it up. But I don't know if you're coming from homes where you're familiar and used to maids picking up after you, but it doesn't work like this in Ireland. So if you make a mess in class, you clean it up after you. And there's people I've talked to before, I remember, in semester 1, about leaving stuff behind, like coffee cups and the like. So look, if you make a mess, clean it up, because there ain't no maids here to clean it up, alright? You clean up your own mess. Okay, so integration of proper partial fractions. So let's have a look at some examples. This week and last week we saw how to simplify these fractions here. Something like this. The only difference now today is we're going to integrate as well. So the part I'm skipping, deliberately skipping because we've done it in class last week, this week and in the tutorial, is how to write this as a partial fraction. So we've seen how to split this up. And after splitting it up, you get 3 over... Why are you late? Come on, hurry up. 3 over x plus 2 plus minus 9 over 3x plus 2. So how did I get from that step to that step? That was the last 2 lessons. So I'm not going over that again. But what I am doing today is then the next part of this question, which is to integrate. So we cannot integrate this, it's just too difficult, but we can integrate this by making substitutions. Let me just make this a bit clearer. I'm going to split this. There's the first piece, dx, and then there's the second piece, dx. So if you remember from our lesson on substitution method, what we have to do here is we say let u equal x plus 2, and in this one I'll use the same letter but it's different here, it's like a separate problem, u equals 3x plus 2. So here you get du dx equals 1, So that means du equals dx, and then here you get du dx equals 3, so du over 3 equals dx. So what we can do now is we can change this into 3, 1 over u du minus 9, 1 over u du over 3. That's really good, because here that's 1 over u du, and then here that's 3 1 over u du. I'm doing a cancelling here. But yes, now see, this is not a problem, but we have to remember I'm being not careless, but you just have to be careful. I know these look like the same thing, but I'm using 2 different u's. So really on my page I should have, like, you know, a dotted line separating the 2 as 2 separate problems, and then we put them back together. Anyway, this here is 3 log u, and u is x plus 2. And then here this is 3 log u, but u here is 3x plus 2 plus c. Now we can actually clean this up a little bit more. We can say this is 3 log x plus 2 minus log 3x plus 2 plus c. And the last thing to do is use the second rule of logs. Log a minus log b is log a over b. So this is finally 3 log x plus 2 over 3x plus 2 plus c. Okay. So that's the first example. So we'll do a couple more.
So it ends there. Bottom part.
Yes, this is it. Now, in the exam, sometimes they want this and sometimes they want this. You just have to read the question carefully. But I think we'll worry more about that when we're doing exam questions. For today, I don't mind too much if you stop here. Be nicer though if you can go to the step. Okay. Let's have a look at another example. Right. I can scroll down. So we have this one. Integrate minus 6x plus 22 over x squared minus 10x plus 25 dx. So again, we use our proper partial fractions, and we can get here minus 6 over x minus 5 plus minus 8 over x minus 5 squared dx. Why are you late, Daniel? No, I really hate this. Get out, you're too late for this class. Okay, so we split this up, and then just to make it clearer, we have minus 6, 1 over x minus 5 dx minus 8, and this here is x minus 5 minus 2 dx. Okay, I'll use different letters this time. So here u equals x minus 5, and here v equals x minus, Yeah, what's the point, because they're the same thing anyway. So u equals x minus 5, u equals x minus 5. There's no point in using different letters. Okay, so in both cases you get du dx equals 1, so du equals dx, du equals dx. So I have minus 6, 1 over u du minus 8 u minus 2 du. So this will be minus 6 log u minus 8 u minus 1 over minus 1 plus c. Like this. That is minus 6 log u plus 8 over u plus c, which equals minus 6, and u is x minus 5, minus 6 log x minus 5 plus 8 over x minus 5 plus c. Okay, you have that one taken down? Yeah. I can scroll down? Alright, so next one here. 6x squared plus 15x plus 45 all over minus 3x cubed minus 13x squared minus 28x minus 8 dx. Okay. Here, Ray, take the headphones out. Okay. Here, I can split this up as 6 over minus 3x minus 1 plus 3 over x squared plus 4x plus 8 dx. Okay, so this one is a little bit different to the other examples I did. The first one is the same, though you let u equal to minus 3x minus 1. I think I'll just clean this up a little bit. I'll take the minus out, so I'll get minus 6, 1 over 3x plus 1 dx plus 3, 1 over x squared plus 4x plus 8 dx. Okay, so this one is different. U, yes, equals 3x plus 1, but in this case we don't say u equals x squared plus 4x plus 8. That's wrong, the second one. What do you mean squared? Complete the square. We need to, here, no, for this one we need to complete the square. If you let u equal to this, it won't simplify. The reason for that, well, maybe I'll let you try it sometime yourself, but if you were to try u equal to x squared plus 4x plus 8, it won't simplify. And basically the reason comes down to the top is too small. Because you know what will happen here, you'll get du dx equals 2x plus 4, and there's nothing on the top to cancel that, not even close. So it doesn't actually make it simpler. Anyways, the way we deal with these problems where we have a number over a quadratic is by completing the square. And in fact, you saw that type of problem recently. It was in the lesson on the tan inverse. Which one was that now? If you were to look for a moment at page before by parts. Yeah, if you were to look at page 26, number 4, just have a quick look at that. Page 26, number 4. You see number 4, page 26? You see those problems? They're exactly the same type as this. So this is why it's important to practice, because you need to be able to recognize when you've seen a problem before. So we've seen this one before on page 26. So the technique here is to complete the square. So we have plus 3, 1 over x plus 2 squared plus 4 dx. Okay, so what's next now? Not quite x plus 2. Yeah, let u, well we'll say v this time. V is root x plus 2 squared over 4. Which looks really, really, really messy. But it's not, because the root cancels the square and cancels the 4. So you end up with v equals x plus 2 over 2. Or in other words, v equals a half x plus 1. And then here we have u equals 3x plus 1. So these are the substitutions we should be using. Here we get du dx equals 3. So that means dx equals du over 3. And here we get dv dx equals a half. So that means dx equals 2 dv. Substituting these back in, I get minus 6, 1 over u, du over 3 plus 3, 1 over x plus 2. Now, I don't know which way you prefer to think about it, but if you want, you could take out the x from here. You could say 2v minus 2 equals x, if you like, from this line. 2v minus 2 equals x. So here we have 2v minus 2 plus 2 squared plus 4, 2 dv. This can be cleaned up. Minus 2, 1 over u du, plus 6, 1 over, and you can see that this one and this one cancel. 4v squared plus 4 dv. This 4 and this 4, I can take it out. Minus 2, 1 over u du, plus 6 over 4, 1 over v squared plus 1 dv. Minus 2, 1 over u du, plus 3 over 2, 1 over v squared plus 1 dv. Yes? This line? Or this line? Here to here? Yeah, here. 1, 2, 3, 4. From where to where? From which number to which number? Here to here? Yes? So what I did was, let's see. Oh yeah, the only thing I did was cancel these 2's because this is a -2 and a +2, so they cancel. And then 2v squared is 4v squared. And then here, 3 into 6 is 2. So I also cancelled this down to make it 2. Oh yes, and here, this 2 multiplies this 3 to make this 6 here. Which 4? Yeah, these are gone. And then this, when it's squared, makes 4. And this 4, that's still at the end. That hasn't gone. And this 2 multiplies this 3 to make the 6 here. And this 3 goes into this 6 to make it 2. I don't know what else. Anything else? No? Yes?
How do you make b like the square root of x plus 2 squared?
Oh, Luke. Page 26, question 4. We had a lesson on it. It is page 26, isn't it?
Yeah.
And it is question 4, isn't it?
Yeah.
Yep. So you got to review that. Okay. Continuing. So this is -2 log u plus 3 over 2. And what's this one here? This is a special one we have already. What is it? Tan inverse, yeah. Tan inverse v plus c. Okay, so we're finished now. You just need to tell me what the u was. What did I say u was? 3x plus 1. And then what was the v?
Half x plus 1.
Half x plus 1? Okay. Okay, you have that now? Yes? Yeah. Okay, now, this is almost like an exam question, except in the exam, they'll add an extra piece to it, which I'll do now. So I'll just go back to the question, I'm just going to add an extra piece to it. What do you think is the extra piece of difficulty I might do here to the question? What might I add to the question to make it a little longer? Add what? No? No ideas? Huh? The what? Say again? Yes. Well, I think we're talking about the same thing. We put in limits. Is that what you mean?
Yeah.
Yes, okay. So in the exam, they'll always do this. So I'll just put in limits to finish it. So 0 to pi. So now I go all the way down back to my answer, and now it's 0 to pi. Now this is very, very important. 99% of the time in the exam, they will want the exact solution here. So does that mean decimal or no decimal answer?
No decimal.
No decimal answer, yeah, the pi in the answer. So, we have to do this without the calculator. What I mean is we have to try and get the exact expression with no decimals. So I put in pi first, minus 2 log 3 pi plus 1 plus 3 over 2 tan inverse pi over 2 plus 1. And then I put in 0, which is minus, well actually this will be log 1, which is gone. So it'll just be 3 over 2 tan inverse 1. Now this here can't do anything with that. And well, you can check it on your calculator, but I really doubt that this is going to be a nice answer. But what's tan inverse pi over 2 plus 1? If it's a decimal, don't bother writing it in. Okay, but I do know tan inverse of 1 is a nice answer. It's pi over 4. Yeah, so you can change this into minus 2 log 3 pi plus 1 plus 3 over 2 tan inverse pi over 2 plus 1 minus 3, what's pi over 4, isn't that what we said for tan inverse 1? So if it's pi over 4, then that would be 8 there, because it's a pi over 4. This is a pi over 4. So that's what they want in the exam. Yes?
Where did the minus 2 log?
Oh yeah, but log of 1 is 0. So if you look, this is an exam question, but you notice it's long and I've skipped something out. What did I skip out? The steps from going from here to here. So this would be part A of the question. And then the integration piece, which starts here, that will be part B of the question.
This would be one question of section B.
Yeah, it's a section B question, and the question will have A, B and C, and A and B together is what I've just done, which will amount to about 10 marks, and then there'll be a part C which will be for 5 marks. And part C is usually something like an integration by parts, or a integration by substitution, or some kind of integration problem by itself. Okay, let me just put this here for you. There you go. Okay, do you have that taken down? Yeah. So, you know... Yes. Because they would say, normally, what is the exact answer? Which is this. There's nothing else I can do to simplify this. Nothing else. Sometimes you'd get 2 logs and you'd have to put the logs together using the rules of logs. That didn't happen here. You know, if there was something like here at the start, 2 log 3 pi plus 1, then because of the minus here you can put them together as 1 log. And that usually happens in the exam, it just didn't happen in this question. So this is the simplest I can make it. Okay. Try some for about 10 minutes and then we'll look at integration of improper partial fractions. I should actually also say it's the improper ones that you see more in the exam, not the proper ones. Although you do get this sometimes, it's the next lesson which is more common in the exam.